All right, welcome to class, learners. With us today, we want to discuss a very interesting topic in physics called circular motion. Please, if this is the first time of coming across this station and this channel, kindly do well to follow for more, subscribe and ask, and let other people in your vicinity know of this. Now, before we calculate this, before we calculate this question, let's talk about circular motion and some other terms to be used in circular motion. So first, what is circular motion? Circular motion can be defined as the motion of an object in a circle or a circular path. As the motion of an object in a circle or a circular path. Next. Terminology used in circular motion. First, we want to discuss uniform circular motion. Uniform circular motion. So first, what is uniform circular motion? We said this can be defined as the movement of an object in a circular path or in a circle with constant speed. In a circular path or in a circle with constant speed. So this one talks about constant speed. Constant speed. Constant speed. So why circular motion? There's no constant speed. It changes, the speed changes. So number two we want to talk about is called centripetal acceleration. Centripetal acceleration. So what is centripetal acceleration? Centripetal acceleration can be defined as the motion of an object in a circular path and is directed towards the center of the circle. I say that again. This is defined as the motion of an object in a circular path and it is directed towards the center of the circle. That is how this is done. So mathematically, we are told that centripetal acceleration is simply acceleration. That's what they're talking about. So we say acceleration is therefore given as velocity square all over radius. So obviously my velocity is measured in meter per second, while this is measured in meter here. So what do we do going forward now here? We say acceleration becomes v squared over r. This becomes equation 1. So the SI unit, therefore, SI unit of centripetal acceleration is simply meter per second squared. So we say that any object that is moving a circular path, its acceleration is called centripetal acceleration. So anything moving a circular path, your fan moving a circular path, its acceleration is known as centripetal acceleration. Don't forget that. Next up, we want to talk about number 3 is centripetal force. Centripetal force. Now, what is centripetal force? Centripetal force can be defined as the force that keeps an object moving in a circle or in a circular path. I say that again. As the force responsible in keeping an object or the force responsible in maintaining the circular motion of an object. So if you see an object moving in a circle, there is a force that keeps it steady. That force is called centripetal force. It's called centripetal force. So mathematically, we say centripetal force is given to be MA. Mathematically, is given to, let's derive it. That's what I'm trying to say. is given to be MA. But obviously, we already know that, here that acceleration has already been given. We have our acceleration given to be v squared. So we have our acceleration. It has been given to be v squared. So because that has been given, we say recall that A becomes v squared over r. So if we replace A into this place, we'll have our centripetal force to be given as M. Remove this A now and put all this one here in place of A. We have it as this. So this is what we have going further. So right where F is known as the centripetal force in Newton, M is known as the mass in kg, R known as the radius in meter, V is my velocity in meter per second square. So this is what we know going further. More also, there are also some things we also need to register as we proceed or as we progress. So from here, what do I know to do from here? We also said that there is what we call angular speed or velocity. Angular speed or velocity. Angular speed or velocity is given as V equals to W. W, or in this case, is called omega. Please don't forget that my angular velocity is known as my omega. Please, omega is known as my omega. So my V is my velocity. Don't forget my velocity. While my R is my radius. So we use the formula as V equals to WR. So these are the necessary things we need to know why we can solve questions like this. And it's very simple. Let's go ahead to solve this. Number one, let's list out the formulas and then we proceed to solving it. So first, okay, so first up, we already know that we have the following formula. Number one, we said that A, acceleration or centripetal acceleration, is given as this over this. Number two, we said centripetal force is given as this over this. Number three, we said that F is equals to MA. As well, if F is equals to MA, we also know that another force can also be mg, mass times acceleration, mass times gravity. Number five, we also note that V is equals to omega R. So where this is my angular speed or velocity, this is my radius and this is my velocity. So these are what we have to solve this question on the board. So let's start solving this question. Let's go ahead. The first question here we want to talk about is question number one. And this is a Waec question. Please do well to make sure that you tell your brothers and sisters, your friends, your colleagues, your church, the mosques about this channel, because this is the place to learn Waec question, past questions in general. So we are discussing the first question, past question here. And the question is this. They said a body moves along a circular path with a uniform angular speed. Don't forget, uniform angular speed. That's my W. Angular speed, that becomes my omega or W. So this is what is given. So let's list out what is given here. So here, angular here becomes my what? 0.6 rad per second square. Oh, and also I did not give you the unit, please. Angular velocity is rad per second per seconds. Rad per seconds. Rad per seconds, please. Did not give you that. Next up, act at a constant speed of this. So speed is given. Our speed is v. V is also known as speed or velocity. So that becomes 3.0 meter per second here. We have to calculate the acceleration of the body towards the center of the circle so that A becomes unknown. A becomes unknown. I also told you in my definition that the speed of an object in a circular path is known as acceleration. Yes. So e.g. your fan, when it grows and maintains that spot, rolling in a circular path, its speed there is known as acceleration. So let's do this one. Now, since we know all of this, this is given, this is given. This is what we are looking at, acceleration in centripetal acceleration. So what do we do? Check this out. If you check this out, you discover that for acceleration formula, we have that A equals to V squared over R. So let's start with that. So we know that A is equals to V squared over R. But obviously, in this question here, we are not giving R, but we have velocity and angular velocity or angular speed. So how do we do this one? It is simple. It is very, very simple. So the first thing we are going to do going forward is that we are going to recall this. We are going to recall this because since we don't have R, this is the only formula that carries R. You cannot make use of this because we don't have mass here. If we have mass, we would have used this. So we cannot make use of this. This one here, we don't have F. We are looking for acceleration, we don't have F. So you cannot use this one. This is what we start with. So we'll just say to get R now, to get this R, what do we say? We say recall that V equals to WR. That is angular speed or angular velocity R. We know our V. Look at my V here. My V in this point is 3 or 3.0. 3.0 is same as 3. So as the case will be. So we know this one. What is this one here? Is 0.6. Then R. We are looking for R. You divide here by 0.6. 0.6. This can cancel. And then if this cancels out, we have that here our value becomes becomes 5. So R here becomes 5 meters. So this is my R. Now, knowing that we have gotten my R, we can now come back to using this formula here, where we say A becomes V squared over R. This is it. So to find my A automatically, what is my V there? My V is 3 and my R here is 5. So if you do that, we are going to have we're going to have 0.6 meter per second square. So this is it. This is how this is done. We're having 0.6 meter per second square there. So this is how it is done. From a formula, we are asked to look for acceleration, centripetal acceleration. So this is the formula. We don't have R. So to get R, simply employ this formula. If you do that, you're going to get your value for R. So if you get that done, then you now come back to this formula, replace in the value and divide, and that becomes your simple answer. So that is how that is done going forward. So now this is the first question here. The body moves along a circular path with a uniform angular speed. Don't forget that angular speed has a unit of rad per second. That's angular speed, rad per second. So that means that we are giving the angular speed here, which is the omega, as what? 0.6 rad per second. Here, this is the angular speed, which is the omega there, W. At a constant speed of this, so V is given to be 3.0 meter per second. We have to calculate the acceleration of the body. So A is what we are asked to look for. So to do that now, we know that A is given as this. So this is the formula for acceleration, centripetal acceleration, which is this one. So we have it as V square over R. That's what we have it as. But observe that we are not given V. So because we are not given V, the quickest thing to do, the quickest way to work on this is simply going to this formula. Because we have V, we have this, we can get our R. So anytime you're not given V or R, if you're not given V or R, you use this formula to get V or R or omega. If you're not given any of them and you need them to solve, use this one. So we say, recall that V becomes omega W. What is my V here? My V is 3.0 or 3, as the case will be. Here is 0.6. Then we are looking for R. So divide here by 0.6, divide here by 0.6, so that this takes off this, and then this takes off this. That will give us what? So our R becomes 5 meters. So since I've gotten my R here, I can simply come back to the formula where we say A becomes V squared all over R. So V squared over R. So that means that since I know my V square, what's my V here? My V is 3.0 square over R here. My R, sorry, is 5. So if you do the math, this one will give us 9 divided by this. So A will give us 1.8 meter per second square. This is how this is solved. And it's well explained and it's simple. Please do well to share this channel. Tell this to your friend. This is the best place. If you are doing Waec, you are doing GC that is forthcoming, you are doing POST-UTME, you are doing, you're already in 100 level, please, this is the best channel to belong. You are most blessed to see this channel. Please do well to share, do well to tell people about it as we solve the next question. All right, welcome to the next question here. We are told that a force F is required to keep a 5 kg mass moving around a cycle of radius 3.5 kilometer at a speed of 7 meter per second. What is the speed if the force is tripled? This is a Jamb question, 2008. Question number 5. 2008. Question number 5. Question number 5. So this is in meter, please. This is in meter. Now, what do we do? Let's check what and what is given to us. So let's check the given value given here. So first, we are told that the mass is given to be 5 kg. Second, we are told that we have the radius to be 3.5 meters. And third, we are asked to find what is the speed. That's what we want to find. We are given, number 3, we are given V to be 7 meter per second. So what do we now do? How do we solve this? First, we want to find V. We are looking for V. That's the O. We are looking for at a constant speed of this. So we are giving V, and we are also looking for V. We want to find V when the question is tripled. They said when the force is tripled, if the force is tripled, what would be the speed? First, we want to calculate if the force is not tripled now, if the force is just one. That's what we want to calculate here. So what do we do? Now we are going to, because they said is a force, we are going to apply this formula. Force, this is the formula here, where we say F becomes mv squared over r. This is it. Now observe that we have the necessary things to solve. So first, we are looking for force. First, we are going to find force first thing. So for case 1, we are looking for force. What is my mass here? My mass is 5 times. What is my velocity here? My velocity is 7 squared all over. This one is 3.5 here. Next up here, I have that 5 times 7 squared will give me 49 all over 3.5. So all over 3.5. So if I have that, what do I know to do here? I can now solve, looking for my value. 5 times 49 will give me 245 divided by this value. So if I do that, I'll have that my force becomes 70 Newton. Now, this is where the force is 1. But they now said, what will be the velocity if the force is tripled? That means if you multiply this by 3, what will be the speed? Will the speed increase or the speed will decrease? That's what we want to do. So next case 2 now, to solve case 2 for case 2 is if the force is tripled. So let's do that. Now you are still going back to the same formula. If the force is tripled, then we have mv squared over r. So here we are looking for v. Now don't forget, because they said what is the speed if the force is tripled. Now that means here that I'm going to be multiplying this by 3. It's 3 because they said it's tripled. So I want to now put in my values now. I have here, F here is 70. So this is 3 times 70 here. The mass, original mass that we are given here is 5 times, we are looking for V all over the radius is still maintained 3.5. So this is what we are given here. Next up, so next up here, if you multiply this, I'll have 2110 here, and then here becomes 5v squared over 3.5. That's what I'm having here. So I'm going to cross multiply. First, I'll put over 1 here, so that would enable me to cross multiply. So do that. We're having this times this one. I'm going to have 5v squared equals to, now I have 210 times 3.5. So here, divided by 5, I have this. So v squared will now give me, that's 210 times 3.5. What do I have there? I have 735, please. So I'll divide that by 5. I have here to give me 147. So find the square root here of 147. So I have this. That will give me 12.12 meter per second. So this becomes how this is solved. It's very simple going further. So case 1, you're going to find the force. Case 2, you will now multiply the value of your force that you have gotten so that you can find the value of the speed when the force is tripled. This is how you do this. And it's a jump pass question. Do well to share this. Tell this to everybody around. Please, if you have not subscribed to this channel, please kindly do well to subscribe, please, so that will enable the others to hear of it and also share of it, and also do well to encourage me as well. See you in the next class. So here is number 3 question in circular motion. So what do we know to do here? We are told that a particle of this mass, so mass has been given. Mass here has been given. So we are told that the given variable here, first, number one, is our mass. Mass is given to be 10 raised to the power of this kg. Is fixed to the tip of a fan blade which rotates with an angular velocity of this. So 2 has been given angular velocity of 100 rad per second here. Then if the radius of the blade is this, number 3, so the radius is given to be 0.2 meters. Then number 4, we are asked to find the centripetal force. And this is a Jamb question. Like I told you before, that in this channel we'll solve several past questions. If you are at 100 level already, if you are planning to write POST-UTME, if you are a Jamb but planning to write Jamb, this forthcoming GC, Waec, that is also forthcoming, all of these exams, this is the best channel to belong. And if you have not subscribed, please kindly do well to subscribe and support me. And please tell this to everybody around, because this is the place where they will get their questions solved and easily explained. Let's go back to that. Now, since we have this, I've already given you the formulas already. So since we are told to find the centripetal force, I am just moving directly to get my formula. My formula becomes mv squared over r. This is my formula. Now let's check if we are given everything here. Observe that we are given mass. We don't have v, we have r. So how are we going to find v? I already told you how to look for v, r, and w if you are not given, and you need to use them. So from this point now, I can say, because I don't have v here, I will just say recall. So recall that my v becomes my angular speed and this. So I don't have this, so I'm looking, I already have this and this, so I have this one and this one. Very simple. Just slot in my value. What is my omega? Is 100 times my 0.2 here. So here should give us 50, if I'm not mistaken. 20, sorry, if I'm not mistaken. So this is over 10, this is 10, and then 2. This will give us 20, please. That is what we are to have as the answer there. So from this point, from here, I've gotten my value now, so I can now solve. So I will say, I'll come back to this point now, because we're looking for F there, where we say mv squared over r. So what is my mass going for that? My mass is 10 raised to the power of 2 times, what is my value here now? Is 20 all over, what is my r here? Is 0.2. Here is 0.2. So what do we do in order to balance this guy here? Now observe that this variable here is given as 0.01. So it's now taken into standard form, because this becomes, if you are moving from right to left, it's plus. If you are moving from left to right, it's minus. So when you take this one here, that is where we have 1 times 10 raised to the power of minus 2. So if you multiply 1 times this one, we'll get it as 10 raised to the power of minus 2. So originally, let's take this one back to the point it was, which is 0.01. So times 20 divided by 0.2. So let's do that quickly. 0.01 times 20 will give us this one. So if you divide that, I'm having 1 Newton there. So this becomes my answer here. It is very simple. Please do well to share, do well to subscribe, do well to tell this channel to everybody around you. Encourage me, please, by dropping a comment and also subscribing. Okay, so we have this as my number 3 question. We are told that the particle of mass this is fixed to a tip of a fan blade which rotates with an angular velocity of this, and then so this is what is given. Now, but observe we don't have v. There is no v here in this value because we have to look for the centripetal force. So using this formula, we don't know V. But are you also aware that we say let V, we say recall that V becomes what? Omega R. So do you agree that this V is what we have here? So what if I remove this V and put this one here? So I would say by substituting V is equals to, in this equation, I'll have that F would give us M. So I will remove this V now and put this 2. So we have W square, R square. Remember, we have R under here. So I have this. So that this R can take care of this R here. So this R remain 1. So we now have that F becomes MW square R. So this is what we are going to use to solve this now. Reason is because, see, we have M here now. This is M. We have omega here, and we have R here. We can find F. So we can just say that F becomes, what is that? So that's 10, this one, times omega is 100 here, square. Please, you have to square it. Then times my radius is 0.2. So from this point, what am I going to do from this point? We know that 100 square here would give us 10,000 times 0.2. So I want to take this one back to its original form. This is 0.01, then times 10,000, then times 0.2. So that's what we are doing. So if you do that, everything here becomes 20 Newton. So this is how this is solved going further. I promise you this is very simple. Please do well to subscribe. Encourage me. Do well to subscribe. Do well to tell people about this channel as we see in the next question. So here is the number 4th question. We are told that the angular speed of an object describing a circle of radius d, so r, is given to be 4 meters, and then a linear constant speed of this, so v, is given to be 10 meters per second. So we are looking for the angular speed. That's what we are looking for. So we don't know it. So what do we do here? We simply say that, recall, we say v becomes W omega r. Omega r. What is my value here is 10. We are looking for this. We don't know this. Times here will give us 4. So if I divide here by 4, divide here by 4, this takes up this. Here becomes 0. Here becomes, 2.5 rad per second. So this is how this is done. Please do well to share. Do well to tell people about this channel. If you're writing POST-UTME, you are in 100 level already. You are planning to write this forthcoming GC, Waec, forthcoming Jamb, and all of this. This is the best channel to be. We solve past questions. This is just a past question, 1995 Waec past questions. We solve a lot of past questions. See you in the other video. Bye.